Okay, section 4.2, powers of binomials. This is one of my favorite sections in chapter 4. I think that it's, I don't know, I think Pascal's triangle is just interesting. The patterns in it are interesting. And the power in using it for expanding binomials, I think is interesting. Maybe that's sort of nerdy of me. But let me first present you with the problem. Okay, here's the problem. If you have something like this, x minus 2, let's say, to the fifth power, okay? You cannot just simply write x to the fifth minus 2 to the fifth, and here's why. This is actually x minus 2 times x minus 2 times x minus 2 times x minus 2 times x minus 2, right? And so what would you have to do? Well, you would have to FOIL this term out, and then you'd have to multiply that result, which would be a trinomial, with this binomial. And you'd have to take that result and multiply it by this binomial, and that result and multiply it by this binomial. It would be insanely complicated. But it turns out, and this pattern was discovered actually before Blaise Pascal. I think he was maybe in the 1700s, but it was discovered in China far before that, over 1,000 years ago. But here's Pascal's triangle as it's come to be known. It starts off in this way. It starts off with a 1 at the top, and then let's get this out of the way here. It starts off with a 1 at the top, and then it has, and then we go 1 for the next row. We go 1 and 1, and then the next row is going to be 1, 2, 1. The next row will be 1, 3, 3, 1. The next row will be 1, 4, 6, 4, 1. And you should try and figure out, can you come up with the next row? Make a prediction and then play the video and see if you get it right. It's going to be 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. And so if you haven't figured out the pattern already, here's the pattern. To get the next row, you always start with a 1, and then you write the sum of the two numbers above it. So 6 and 1 is 7. 6 and 15 is 21. 35. 35. 6 and 15 is 21. 7 and 1. And then we'll do another one. I'm not really sure how many we need here, because once you get what you need, once you get to the pattern, you don't really need the extra rows. You can always just build the row that you need. So then 56, and then 70, and then 56 again, and you can see it counts down, so it's going to be 28, and then 8, and then 1, okay? And each row corresponds to a particular power. So this is the top row is the 0 power. Mr. Cresswell, how does that work? Well, anything to the 0 power is just 1. So x minus 2 to the 0 power is equal to 1. All right. And then the next row is to the first power. And then the next row is to the second power, and then the third power, and then the fourth power. Make sure I'm doing this right here. Second, third, fourth, and then fifth. Sorry, this is looking a little bit sloppy, but I'm not actually going to write the rest of them out. It's just remember that you're always going 1. It's, you know, the first row goes with the 0 power. The fifth row is going to go with the fourth power. So this is 1, 2, 3, 4. Fifth row will be for the fourth power and the fifth power, and so on down the line. Okay. I guess if okay, I'm changing my mind mid-lesson here. I guess I'm going to write these down. So 1, 0, 1, 2, 3, 4, 5, 6, and then 7 power, and then this last row that I have here is the 8th power, okay? So how does this actually work in practice? Well, what this tells you is in a simple binomial expansion, where a binomial means two terms here, in a simple binomial expansion, these are the coefficients, the numbers out in front of the polynomial, okay? So let me show you how this works with x plus y to the fifth, all right? So here's my process. There are 2 steps. First step, find the row of Pascal's triangle and write out those numbers, giving yourself plenty of space, okay? So if I'm taking to the 5th power, then I'm going to go to the 6th row. So 1, 2, 3, 4, 5, 6. Here's my row, 1, 5, 10, 10, 5, 1. So I'm going to write those numbers out. Excuse me. 1, 5, 10, 10, 5, 1. I'm going to give myself quite a bit of space. Then I'm going to take whatever the first term is. So the first term here is x. I'm going to take that, and I'm going to write that to the 5th power. And then I'm going to count down going to the right. So I've got x to the 5th, x to the 4th, x to the 3rd, x to the 2, x to the 1, and x to the 0. All right. Now I'm already at the right-hand side, so I'm going to start there and go back the other way with the other term. So I'm going to go x to the, the other term is y. So I'm going to take the second term, which is y, and I'm going to go y to the 5th, y to the 4th, y to the 3rd, y to the 2nd, y to the 1, y to the 0. If you don't have 0 at the end, then you did something wrong. You should always get down to 0. Okay? Then I check my sign on the middle of the binomial. Here it is plus. So if it's plus, everything in between these terms is plus. So just write plus all the way down the line. Okay? And that's it. I'm sorry, that's not it. That's it for getting the first half of this problem. The second part is simplifying. Okay, so then the last thing we'll do is simplify this as best we can. So 1 times x to the 5th times y to the 1. Y to the 1, remember that's just 1. Sorry, y to the 0 is just 1. Okay, so all I have here is just x to the 5th. Plus 5 x to the 4th y plus 10 x cubed y squared. Nothing simplifies on these. 10x squared y cubed plus 5x y to the 4th. 1 times x to the 0, which is 1, so then just plus y to the 5th. Okay? So there's that example. And that's it. So this would be 2 points. It'd be 1 point for getting this unsimplified version and then a point for the simplification. Okay? Simplification wasn't too bad in that one. All right, next one here. We're going to go 2x minus 7 to the 4th power. So if I've got the 4th power, I'm going to go to the 5th row, which is right here, 1, 4, 6, 4, 1. Okay, and I'm going to write that out, those coefficients out, giving myself plenty of space. So I've got 1, 4, 6, 4, and 1. Maybe I can give myself enough space. We'll see. All right. And now that I've written those out, I'm going to take the first term, which is 2x. I'm going to be very careful now. It's not simple like x, right? It's got a 2 in front of it. So I'm going to write that out as 2x. I'm going to use parentheses, and it's 2x to the 4th power. So 2x to the 4th, 2x to the 3rd, 2x squared, 2x to the 1, and then 2x to the 0. Okay. See why you need a lot of space. All right, so then I'm already at the right-hand side, so I'm going to go back the other way with the other term. The other term is 7. Ignore the sign in the middle for now. Okay, don't do negative 7. It will just be confusing. Take 7, and you're going to go 7 to the 4th, 7 to the 3rd, 7 to the 2, 7 to the 1, 7 to the 0. Now, check the sign. If it's negative, then you're going to start off with positive, and you are going to alternate as you go down the rest of the terms. So it's going to be positive, negative, positive, negative, positive. Okay. Sorry, it's got a little confusing here on the right. Okay. Now I'm going to clean it up. I'm going to have 1 times 2 to the 4th. 2 to the 4th is 16. So I'll have 16 times 7 to the 0, which is 1. So it would be just 16x to the 4th. Okay. Here, I'm going to have 4 times 2 to the 3rd times 7. So there's not a really good spot to write this down. On the whiteboard, I would just write it off to the side. So for this one, I'll write it out once. 4 times 2 to the 3rd times 7. So in your calculator, you just put all of that, okay? You can use Desmos if you want to. So it's 4 times 2 raised to the 3rd times 7. 224. So it's going to be minus 224x to the 3rd plus, this will be in my calculator, I'm just going to go 6 times 2 squared times 7 squared. 1176 x to the second power minus 4 times 2 to the 1, so that's just 2, times 7 raised to the third power, that's 2744 x plus, and then the last one's going to be 1 times 7 to the fourth. So 7 to the fourth, we've got to figure that out. 2401. Okay, so that's the final version of that. Now you might think, wow, that was really difficult, but just imagine going 2x minus 7 times 2x minus 7 times 2x minus 7 times 2x minus 7 and so on down the line. Okay? All right. So how are we doing on time here? 11 minutes. Okay. So let's go. Here's what I'm going to do. I'm going to do one of these down here, number 4. I'll do number 4, I guess. And then I'm going to write I'll do a second video of number 3 and number 5. If you think that you get it from the first video and you don't need the other one, then that's fine. You're good to go. But if you are still confused, you want to see another example, go to video 2 and you can see me do number 3 and number 5 for a couple extra examples, okay? So let's find the third term of x plus y to the 8th. Now, one way to find the third term is just to write out x plus y to the 8th, all of it, and then find the third term. Okay, but it turns out that we don't really need to do that if we can use Pascal's triangle and what we know about these in general. So let's see if we can do that. All right, so third term of x plus y to the 8th. X plus y to the 8th, that would mean we'd need to go to the 9th row up here, which is our last row, and we want the third term. Okay, so the third term would be 1, 2, 3. So that'd be 28 would be the number we would take from there. So we're going to have 28. Okay, and then we think about this. Well, imagine, I wish I could put this all on the screen here. Maybe I kind of can. Not really. All right, so what we can do, though, is we're going to go, the process would be to start with x to the 8th, and then we would count down, right? So it'd be x to the 8th, x to the 7th, x to the 6th right here. So I'd have x to the 6th power there. And then you'd be counting from the other way. We'd take y, right? And we would start at y to the 8th and go backwards all the way to 0. So this would be y to the 0, y to the 1, y to the 2, right? So my third term would be y squared. So I don't need to write the entire thing out. I can just kind of hack what I know about binomial expansions plus whichever row I need from the Pascal's triangle to get that specific term, okay? And that wraps up section 4.2. Like I said, I'm going to make a part 2 video that'll explain these last 2 examples, but that's really the basics of powers of binomials.